So this is Haibo, and so now, James and I are going to talk about how we leverage Pinot at Uber for large-scale analytics. So here's the agenda. So first, we'll talk about how Pinot is used at Uber, and then we'll talk about two contributions that Uber contributed. One is querying Pinot with Presto SQL, and two is Upsert, which aims to make real-time data mutable. So first, Pinot at Uber. So this is a team as of April. So Pinot has been used at Uber for more than 4 years, serving hundreds of tables across a wide variety of products at Uber. So they mostly fall into two categories. One is live dashboards, and two is ad hoc queries. So for live dashboard, this is a sample example. This is an example of our East dashboard, where our local operators can just see the live health of the East marketplace. For example, how many couriers are online and how many orders were created in the past 5 or 10 minutes, and as well as how many orders didn't get delivered and things like that. So they can see all those real-time metrics and take actions when needed. So the second category is ad hoc queries. So internally, we have built a self-serve onboarding portal where users can just prepare their real-time data source from Kafka and then create a table. So this is especially in the beginning when they want to see what the data looks like, and they can tune the query and tune the table config or schema as needed. And then until things get stabilized, and then they can just productionize the use case either into a dashboard or some other places. Uber has been actively contributing to the Pinot community as well, based on the feedback that we receive from our users. So this is just a selective list. So first is Presto connector, which allows querying Pinot data by writing Presto SQL. And second is Upsert, which aims to make the real-time data mutable. So we're going to talk about the first two in today's talk. And apart from that, we're also working on deep store decoupling, which aims to make the real-time ingestion more flexible and reliable by removing the hard dependency on deep segment store for low-level consumer. And of course, also a schema evolution, which fixes the data integrity issues when adding new columns to the real-time table. So after that, you can just add new columns on the fly without data integrity issues. So first of all, it's about querying Pinot with Presto SQL. If you remember our second category of use case, we have a UI where a user can just type their query and then get the result. So as time goes by, so originally people were fine with learning the PQL, which is a Pinot query syntax. But then limitations just surfaced because as users want to apply more complex business use logics. For example, they couldn't do joins between Pinot and other warehouse tables, and they wanted nested queries. And the third category is internally at Uber, we wanted to have a standard SQL interface across all backend. Because for our analytics tech stack, we use Presto mostly for batch data, where data sits in HDFS. And for real-time data, we have Pinot and also a ArisDB, which is another real-time data store developed at Uber, powered by GPU. So Pinot uses Pinot QL and ArisDB uses AQL. So we have 3 core interfaces for our analytics backend. And we want to unify that and use SQL as the only way. So as we mentioned, Presto has been widely used at Uber. So it's a distributed SQL query engine that allows users to write SQL queries to access various underlying data source. So Presto, of course, its advantage is that it supports a full ANSYS SQL. It's flexible. But in terms of query latency, it's usually seconds to minutes, depending on the data size. And data freshness, since its primary data store at Uber is data in HDFS, so data freshness usually is hours or even up to a day still. And whereas for Pinot, the data freshness is usually seconds to minutes, and query latency is also milliseconds to seconds. But the limitation is that it doesn't support join. It it supported really limited UDF. So looking at both these systems, what if we can find a way to get the best out of the two? So that wouldn't that be awesome? So let's look at the Presto architecture. So Presto mostly has a coordinator and worker. So when a user comes in, the coordinator would parses the query, generates the query plan, and then generate an execution plan. And then each worker would actually get assigned the splits and then query the raw data from the underlying data source. And after that, the raw data would be aggregated, and then the result will be sent back to the user. So if we look at the underlying data source, so Haibo, Cassandra, and all those data sources are supported. So it's a natural fit to just plug Pinot as another data source. So here's how we did that. So when the query comes in to the coordinator, it would query Pinot to get the routing table. So if we look at how data is stored at Pinot, so Pinot, each table is comprised of different segments, and then each segment would store in each server. So the routing table will basically tells for each table what segments is contained in this table and where does each segment live in which server. And after the query plan is generated by the coordinator, it would assign the splits to the worker, and then each Presto worker would fetch the raw data from Pinot, and then that would be aggregated as usual and be returned to the user. So here's the current status. So this Presto connector has been available in Presto DB, and it's executed in two modes. One is what the code name is Photon, which is what we have seen earlier. So it's basically execute in regular mode, similar to all the other connectors like Haibo or Cassandra. Of course, possibly it can have a higher latency compared to querying Pinot directly, because each Presto worker is actually always fetching the raw data from Pinot, and then that will be handled afterwards within Presto. When the data volume is really huge, actually it would result in a significant query latency overhead. So we implemented, so in order to reduce the amount of data transfer over the network, we implemented a predicate pushdown and limited pushdown, and also some select aggregate pushdown. For example, if the query contains count or sum and things like that, we would actually let that happen within Pinot, and instead of passing all raw data to Presto. After implementing this, our awesome colleagues at Uber's Presto team brought this aggregate pushdown to the next level. So which is another component called codename Neutrino. It would actually query Pinot broker directly. So instead of only supporting limited aggregate pushdown, this mode will actually support full pushdown. And so Pinot would do things like group by even within Pinot, and then the result is sent back to Presto. So as a result of this, we are seeing very little query latency overhead. And this is still being actively developed. At this time for Neutrino, Join is still not supported that. It's supported right now, but we are actively working on, the team, Presto team is actively working on that. So this is the current status of querying Pinot through Presto. And next, over to James to talk about Upsert.
Thank you, Haibo, for the great introductions about how we use Pinot and how Presto, oops, sorry. Let me go back over here. Yeah, and also how we utilize Presto to help us to make Pinot more performant and also scale up to multiple use cases. And in the last part of the presentation, we're going to talk about Upserts. We're going to go through why and how Uber take this initiative and adding the Upsert support to Pinot. So first, before we talk about Upsert, you might have a question of what is Upsert and why do we need it? So basically, we can look at these things a little bit simpler. So Upsert means that sometimes we not only want to have data just append to Pinot, which is what Pinot originally support. We also want to be able to update the data in Pinot as we ingest the data. So let's look at what is the current status for data update in Pinot. You could run some kind of an offline job to backfill data from your deep storage system. Either it could be Hive, HDFS, or S3, or any system you choose. But one of the big problem we found is first is usually those jobs are slow, and it has a latency to wait for data to be available on those deep storage system. And also you have inflexibility of whenever you update a small part of data, you need to run the backfill job for a large set of data, either for hours or even days. So it becomes really expensive to do that all the time. And one of the most important things is that there's low real-time updates available for this kind of models. And let's look at why we at Uber have this kind of real-time update requirements. So first of all, we have some technical reasons. For some of the streaming processing pipeline, either by the design of our clients or by the design of our users, they might have a large data duplication waste whenever they restart the job or restart the service. So we want to have some mechanism to help our users to duplicate data if that is one of the expected behavior and they want to avoid it. And second is a business use case. We have a lot of business use case where we want to be able to serve the real-time data, for example, buys, Uber cars, or maybe Uber Eats order to our users really quickly. So let's go to a couple of examples. So first example, for the jump buys or scooter, those kind of monitoring. So in a lot of the our business use case, we might want to provide those the bikes location or scooter location either to our ops people or to some government agency. So when we need to do that, we need to provide basically we want to ask a question of how many bikes or scooter is in a particular regions at a given day or maybe by a certain conditions. So in order to do that, we basically need to get all the GPS location data of all the bikes and scooters and use the latest copy to do a count. If without the upsert, it becomes really difficult things to do in Pinot because you're basically trying to do the count on large set of data. But if you have an upsert, then you will always going to keep the latest copy of all the bike or scooter location data, and you will be able to return that result really quickly. And in the second part, so we can look at the Uber Eats restaurant managers. Whenever you do any operation on the Uber Eats, you can think about you submit an order to the restaurants, and the restaurant will be starting to process your orders. As the restaurant is processing the order status could change. And each time the order status change, it will generate event to the Kafka. So all those type of different type of order status change, they will show up as one individual entries on Pinot. And think about the cases where our city art people, they want to do monitor. For example, they want to ask a question. What is the average time of each restaurant when they for preparing an order or for finishing an order? If you want to do that over all those data, it becomes really difficult because you have all different type of data showing up for the same orders. And you might get a duplicated result or you might get an inaccurate statistics for the analyst. So the upsert in this part will help us to be able to achieve these things a lot quicker. So let's look at upsert in a little bit technical details. So first of all, what will be the upsert? How will upsert work? So first of all, we have all these Kafka events. So let's assume we're using Kafka as an ingestion mechanism. So we have all these events coming into the Pinot, and right now in the Pinot storage system, we just append them to the Pinot table, regardless of what they are. However, what we want to achieve with the upsert feature is that we want to be able to identify, first we want to indicate a particular column as a primary key. So in this case, the order ID will be the primary key. Then we can make an assertion saying that every record with the same primary key will only keep one and only one copy. And that copy will be decided on certain criteria. So for example, in here, we're going to choose the timestamp as a deciding criterion for upsert. So for all the record coming in, we'll only keep the one record with the highest timestamp. So in this particular case, that will be the second record with the timestamp equal to 120. Then you might ask, how do we want to do that? So generally, in order to update the update mechanisms, you have two ways to approach this. First, you could either to directly go to the physical data storage of that one record, and you could change that physical data. So right now, it's a little bit difficult to do that in Pinot because in Pinot, we're trying to use a columnar storage. So that is not a really reliable approach. The second approach, which is the one we're using, is we use a deletion marker, or in our particular case, we call it versioning. So you can think about in each of the record, we were keeping the version of that particular record. And in simplest field, we're basically adding two columns to these Pinot tables. So one is a valid from, and second is the valid until. So valid from will indicate, basically it tells our users at which version a record should become visible to the users of that table. And the second is the valid until. So valid until is basically indicate at which version a record become invisible to the users, aka the record has been deleted. So let's say, look at this example. You have the first record. We have this valid from with the version. So we can say that this record is visible from version 100. And if you have a second record comes in, and the second record will associate with a different version numbers. Because it comes in a later timestamp, so the version numbers for that record is going to be bigger. So for example, in this case, the second record will have the version number of 120. And you can see that we will also update the first record for its valid until version to 120. So these ways, we were able to, as long as we pick the correct version numbers in our query, we can rewrite our query to make it to filter out the older record with the valid until version smaller than a certain value. So for example, in this case, if our valid version is 130, we can see that we can filter it by picking valid from less than 120 and valid until bigger than 130. So this way, only the second record will show up in our users result or in users aggregations. So let's go into a little bit more technicals about how we implement this. So basically, Upsert in Pinot in our current architectures, it consists of three major steps. The first step is we want to locate the most recent record for a primary key, the key space management. Second, we want to update the record with correct version values. And the last, we want to maintain the current version and be able to rewrite the query on our broker side. So first, look at how do we locate the most recent record for primary key. So in order to do that, we're adding a new component to Pinot. So you might have already know Pinot has a Pinot server, Pinot controller, Pinot brokers. We're adding these new components called Pinot coordinators. So coordinators will handle the management of all the keys in the key space. So for example, for primary key, we will store all the associated metadata. And whenever we ingest a new record into Pinot, so let's look at, for this particular example, we ingest this new record. What we will do is we utilize a Kafka topic as a buffer between the two components, the Pinot server and Pinot coordinators. Pinot server will send the primary key and the associated metadata to these Kafka topics. And you also partition by the primary key. So this way, our coordinators can just fetch the data from a certain Kafka partitions. And those data in this Kafka topic will go to one of the coordinators. And the coordinators will update its internal storage. So for example, in its internal key value store, we will store the primary key, which is ID1, and it's a list of its associated metadata. So in this particular case, it will be 1, 2, 3, or whatever other metadata like segment names, offset, those kind of things. So this is how we manage or keep track of the record of the primary key to metadata mappings. In the last step, we want to update the record with the versions, aka the valid from and valid until columns. So in order to do that, we utilize a separate Kafka topic. So this Kafka topic will store the segment update event. So basically, it's whenever we update the events on the coordinators, we will send the event out to these topics. And on Pinot servers, we will have this segment updated components. This segment updated components will basically fetch the data on these Kafka topics and update the valid from and valid until columns. So in this case, because this will be an insertion event, so we will be updating the valid form of this record on the Pinot server 1, and we'll update it to 100. So let's say that on Pinot server 2, we have a second record comes in with a different timestamp, but the same primary key. So this record will be embedded to this Kafka topic as well. And Pinot coordinators will fetch this event from the Kafka topics. And it will update the internal metadata store to the latest copy of the primary key. This event, so whenever we update the event to in the coordinators, we will also generate some event to the segment update event Kafka topics over here. So the first event we generate is a deletion event. So this deletion event will be pulled in by the Pinot server 1, and we'll update the valid until columns for this primary key for this timestamp at this location, and we will put the valid until 120 to its valid we'll update the valid until column to 120 because this is a deletion event. And at the same time, we'll also generate an insertion event. So this insertion event will be corresponding to the new event we just ingested on the Pinot server 2. So you can see that in this particular case, we'll update the valid form for the second record to be 120. So this is an overview of how Pinot Upsert work for managing the key and managing the version numbers. And this is the very complicated diagram we have in the design doc. And if you're interested in how exactly it works and why we have all these different components, feel free to take a look at our design doc to see how each component interact with each other. And last thing we need to do as well is that we need to maintain the current version and we need to rewrite the queries on the brokers. So think about each of the Pinot server, they can do all the update by itself, and they can manage what's the version it has processed up to. But different server, they can have a different process or a different progress or different speed because of whatever the buffering on the Kafka or buffering in these injections. So Pinot broker, we want to do a synchronization across all different servers. Basically, what we do in here is that Pinot broker will go to different Pinot server and ask them what is the latest version you have ingest up to. After Pinot broker get that information, you will use it to pick a safe version, and this safe version will be used in the query one. So for example, in here, you can see server 1 and server 2, the safe version in this case will be 101. So we will use 101 and use that to rewrite the query. So basically, that's how the Pinot Upsert work in our current iterations. So the current status of Pinot Upsert at Uber is that we have deployed in production with the use case from Uber Eats and our scooter side business. In our staging table side, we have a little bit more traffic that we are doing the testing and validation. We are about 10K plus ingestion rate with 7 to 14 days of retentions. And we are currently gradually merging change back to upstreams. And hopefully in the last couple of months or so, we can get all the change back to upstream so that people can try out. And that's all the thing we want to talk about today for the Pinot Upsert side.